Good afternoon, everyone. Welcome to Retrofit Talks. I'm Patty D'Souza, the Public Program Curator and Digital Curator at the Building Center. I'll be the host for today's session titled Extending the Life of Heritage Multi-Unit Residential Properties. This online talk series, which is part of the Retrofit 23 exhibition, connects professionals to discuss residential retrofit. We're here to showcase the latest research and projects in architectural practice, offering valuable case studies and solutions for retrofitting homes. Our guest speakers will present their projects, followed by an interactive Q&A session. Now, please join me in welcoming Rebecca Thomas, Director at Fathom Architects, James Hinks, Associate at Elliott, and Matthew Barnes, Project Director at Hoare. From identity and environmental performance to accessibility and well-being, our speakers will discuss how a residential retrofit project, St. Mark's Court, successfully created a desirable residential development of 29 homes with research, sustainability studies, and bespoke suppliers. And now over to Rebecca Thomas, Director at Fathom Architects.
Welcome. I'm Rebecca Thomas, one of the directors at Fathom Architects. And today I'd like to talk to you about our project, St. Mark's Court. Since the most sustainable building is one that already exists, it's essential we find ways to reuse these in a sympathetic and pragmatic approach. At Fathom, we see a retrofit as an opportunity, not a constraint. Today, I'm going to talk to you about third generation retrofit, how we worked with the context and history of the site and the building to create unique homes, how researching the original building will help us unlock the layouts internally, and how you might improve the accessibility of existing buildings and how to upgrade the building fabric. Any retrofit project should be a collaborative process and working with the design team to share the knowledge and expertise to help us create better homes for the future. In that in mind, I'd like to then pass on to Matthew Barnes at Hoare, who will talk to us about the thinking strategy they've developed for the scheme, and then on to James Hinks, who will share Elliott Wood's creative and technical approach to adapting the structure. St. Mark's Court is located in St. John's Wood Conservation Area in North London. The conservation area is characterised by its leafy residential properties, both a mix of mansion blocks and terrace housing. We sit on the corner of Abbey Road and Abercorn Place, just up from the pedestrian crossing where you might recognise the Beatles crossing previously. Our building sits as a transition between both these two types in its location and also its typology, which I'll explain further in a minute. With its prominent corner location, it's helped us to explore the massing of the scheme and ways that we might create new homes. The building started off originally as 6 terrace houses built in approximately 1860s and 1870s. In about 1916, Miss Willie James founded the Housing Association for Officers' Families. She was a great hostess and socialite for the period and set up the charity to support widows and children of officers who died during the First World War. They acquired these 6 terrace houses and then undertook a major retrofit in approximately 1920. When they converted the 6 separate homes into a single block of 24 flats. Some of the major works involved included removing all the internal staircases and introducing 2 new cores into the building. All the individual front doors were relocated from Abbey Road to create a new single point entrance at the rear of the scheme off Abercorn Place. With the reconfiguration of the internal layout, new windows were required and some major alterations were undertaken to the facades, particularly at the rear, and then all the brickwork was painted over to conceal these alterations. One of the great challenges we've faced and questions we've been battling with throughout the project was whether this is a mansion block or a series of terrace houses. Obviously, it started life as one and it's merged into the other. Trying to answer these questions, balancing and negotiating this has led to our overall solution, and it's something we are still testing as we continue on with the project. Understanding the complexities of the scheme and its location has enabled us to work out ways of introducing more mass and volume onto the site to enable us to create an additional 5 homes, taking the total to 29. We've managed to do this by creating a mixture of homes from studios right up to large 3-4 bedroom family size units. We look to extend the rear of the building at the back of the scheme. This allows us to increase the size of the apartments to meet modern current day standards. We then removed the existing 4th floor mansard roof and have extended it up to create a new attic story of accommodation following the character and proportions of the facades below. On top of this, we've created a new 5th floor mansard roof with terraces to the rear to create outside private amenity space. By pairing the 4th and the 5th floors together, we've created duplex apartments that provide the larger family accommodation. We've then looked at putting a basement underneath the entire of the scheme. This allows us to create a new plant room to meet the new servicing strategy for the scheme, and then also house a new cycle store for the residents. We then take the remaining space and pair this up with the ground floor to create further duplex apartments with their own private courtyards. By researching and understanding the historic plans and layouts of the buildings has enabled us to create some characterful layouts. The current scheme doesn't comply in terms of either space standards of the flats, each of the individual rooms, or the fire standards required for modern residential schemes. We started off by trying to work with the existing 2 cores, extending these with the lobbies and lifts, and found that we were getting quite compromised internal layouts. We then looked at the possibility of removing one of the cores and creating 2 cores, therefore enabling us to get 6 flats per floor and improving efficiency. What really unlocked the internal layouts was going right back to the terrace houses and working out where the existing staircases would have been located. Looking at the rear of the building, you can see the windows that were replaced with these 2 new windows with a central mullion. This is where we think the original staircases would have been. By relocating our new core against the facade in one of these locations, it helped us unlock the width of the building and improve the internal layouts. This is slightly counterintuitive as to where you would put modern cores centrally into the scheme to maximise the daylight and facades. But it's important to remember that obviously historic buildings all have their own unique characteristics, and that doing things slightly counterintuitive is actually the best way to create homes fit for the future. We then move on to the next level of detail. We wanted to work with the existing building and retain as much of the internal structure. So we kept in the original spine walls in between those 6 terrace houses, and then just started to remove and adapt them where required to create the new layouts. We needed to minimise as much of the internal circulation space within the scheme to maximise the spaces we've got for habitable rooms, and therefore we've gone for an open plan approach to the layouts. We've tried to create and locate the entrance doors to each of the properties centrally, again to minimise any internal circulation space. Right back at feasibility and stage 2, we looked at what our strategy might be for upgrading the building fabric, and determined that an internal insulation system was required due to its location and the conservation area. We therefore allowed the zone around the external facade and increased this to accommodate insulation from day 1. This means that as we've been working through the detailed design and we take the building to site, our space planning internally and size of the departments won't be affected. Also understanding the service strategy right back at day 1 in the feasibility stages enabled us to ensure that we've got utility cupboards that are large enough to house the MVHR units, and that these are all part of the initial design from day 1, and we're not trying to squeeze things later on further down the line. One of the other things we really wanted to do was reactivate Abbey Road. Historically, the 6 terrace houses each have their front door facing this. As these were removed, we then ended up with quite a large blank facade facing the road and not really interacting with the conservation area. By relocating the main door to the scheme onto Abbey Road, it's a wider benefit to the whole area and the conservation area. Improving accessibility in historic buildings can often be a challenge. We were lucky enough that in the first phase of retrofit, they introduced a half level to the rear of the scheme, for which we were able to work with. We still maintain the steps level access at the front in relation to the original entrance doors, but we've relocated a lift to the rear of the scheme, allowing us to have level access to all apartments throughout the building. One of the challenges of introducing a lift into a conservation area is the impact the overrun can have on the wider context. By pairing up the 4th and 5th floors into duplexes, we're able to terminate the lift at 4th floor level and therefore avoid any overrun beyond the envelope of the building. Enhancing the existing character of the building is always key to creating a new identity, and we were able to have fun with some of the historic features that the building either originally would have had or still currently has. We increased the height of the bay windows, introducing a new bay window at 3rd floor, and added some contemporary detailing such as the brick cornice lines and the metalwork to add that finer element of detail that was missing. Then at the rear, where we're creating the new extensions, we were able to have a little bit more fun with this historic detailing and be a bit more playful with some of the brickwork. Due to the massing increase, we've then increased the heights of some of the existing chimneys. As these are no longer featured as working chimneys, we were able to be far more playful and introduce windows into these to create unique features for the apartments. During the planning process, we were in a continual dialogue with Westminster Planning Department. We undertook 3 pre-apps and various other design reviews to settle on a final scheme. We were very empathetic to the conservationist point of view, who would have liked to have seen the building as 6 terrace houses in its expression, whilst understanding that it is actually a modern mansion block. We straddle not only the typology of the building, but also policy. If we'd have turned it back into 6 homes, we would have had a very happy client, but we wouldn't have been compliant in terms of the loss of home provision or the size of these apartments. There is always a compromise to be taken and design challenges that need to be sought when doing this. And we compromise by introducing party wall, upstands and chimneys to reflect that original division of 6. We've ended up undertaking these in lightweight GRC to reduce any impact that these will have in terms of structure, cold bridging and detailing, and are going to continue the exploration of what we might use these for in the future and if they have any purpose. We obviously have a new facade that's now a mix of existing solid masonry and new brick cavity walling. Understanding the buildability and the construction will help us design robust details as we go forward. We've therefore chosen to extend the existing solid masonry up in green highlighted on the diagram on screen to ensure that our junctions between old and new sit in line with some of our detailing. This enables us to create flashings between those 2 new different types of construction over the cornice line without impacting the overall appearance. Reviewing and simplifying construction methods, the amount of demolition you're doing and where you're detailing those joint lines between new and old will ultimately allow a much more robust scheme going forward once you hit site. We are then looking at upgrading the building fabric and are currently working with specialists to seek expert advice to ensure we don't damage the fabric. We're doing testing on site at the moment with PAY on removing the existing paintwork, as it is unlikely that this is breathable. We then think the whole scheme was repointed in cement mortar, and then therefore looking to remove this and repoint if needed with lime. Internally, we're then looking to insulate the brickwork with a hybrid product of diathanite plaster. This is made from cork and clay and is sprayed directly onto the internal face of the brickwork wall. Paired with this is then a layer of calcitherm. This is a calciate board that's made of sand and lime and is naturally non-combustible with an A1 fire rated class. It also has properties that help with the humidity and quality of the internal airspace. In light of that, this is just a small part of the sustainability strategy for the scheme, and therefore I'd like to pass over to Matthew Barnes, who will elaborate further on the servicing and sustainability strategy for the building. Thank you.
Thank you, Becky. Good afternoon, everyone. My name is Matt Barnes from Hoare. I'd like to talk to you today about the role and the approach that Hoare have taken to the redevelopment of St Mark's Court. We've been looking at the MEP, the fire, the acoustics, and the energy and the sustainability. Next slide, please, Becky. So I'll give you a quick overview of what I'm going to talk to you about today. I'll touch on the aims and the objectives at the start. We'll have a quick look at the existing building and the servicing strategy we found in place on the surveys conducted at the outset. We'll talk through from a high level perspective of the energy and sustainability strategy, looking at where we stand against the Part L building regulations. We'll have a quick look through on the thermal comfort and overheating assessments that were carried out early in REBA Stage 3. We'll talk about how the acoustics and the fire engineering consultants have fed into the wider design team coordination and key aspects of those strategies. And then also I'll talk to you about the MEP integration and the incoming utilities and infrastructure specific to St Mark's Court. Next slide, please. So at the outset, given that it's a refurbishment of an existing residential building, it was agreed between the client and the design team that we would follow a fabric first solution, looking to upgrade the performance of the existing building fabric, as Becky mentioned, the walls, the roofs, etc., and replacing thermal elements such as windows where performance just wasn't at the required level. We look to develop servicing proposals that are aligned with the client brief to create a high quality residential environment. I think it was important for us to establish parameters that the MEP or the proposed MEP solutions needed to be assessed against. So we looked at technical suitability, energy and performance, spatial integration and the impact on net area of the apartments, alignment with the development cost plan, and then last but not least, of course, the planning and the conservation area requirements and constraints that need to be taken into account. And given where we are in the 21st century with all the regulations, the guidance, the technologies that are available to us, it's always important to remind yourselves when working on residential developments, homes that for people to live in, that we're looking to create a safe, energy efficient, comfortable and intuitive place for people to live. Next slide, Becky. So we undertook a survey right at the outset after being appointed on the project to establish the type and condition of the services within the existing building. Predominantly throughout the different apartments, there was aging natural gas fired combination boilers for the heating and hot water. This brings with it its own inherent constraints and health and safety considerations when there's flues running through ceiling voids of residential dwellings. And the architects were keen if we could try and find a way of omitting the flue penetrations through the external elevations. This combined with the drive to decarbonise the building, we decided fairly early on we would remove the requirement on natural gas and it would be an all-electric solution for the building that we would develop. The existing ventilation is fairly minimal and ad hoc within the building. It's quite reliant on openable windows for the ventilation achieved inside at present. There is some mechanical ventilation in the form of local extract through the wall from wet rooms and kitchens, but nothing, as you'd perhaps expect from a building of this age, in the form of heat recovery. Domestic hot water is generally from the gas-fired boilers or electrically generated, and low energy lighting is fairly intermittent throughout at present. And just to note the final point there, the electrical installation was significantly dated and needed to be brought up to current regulations and standards. Next, please, Becky. So on the energy side of things, the design was commenced in 2021, and we've therefore been assessing against a Part L 2013 baseline. The existing dwellings have been assessed against Part L1B, and the new dwellings have been assessed against Part L1A. From the graph on the right, you can see we created a Part L model of the existing building, partially from survey and partially from some assumptions based on age of thermal elements. As you can see, we achieved quite a significant performance betterment against the baseline from the B-lean stage of the energy hierarchy through pushing the building envelope, the fabric, the glazing, the low energy lighting. There wasn't anything at the B-clean step. We don't have any heat networks or CHP on this project. And then a further 5% improvement over the Part L baseline was achieved through the integration of renewable technologies, which I'll cover a little bit later. And just to mention also, from the outset, we have been investigating BREEAM domestic refurbishment for the refurbished dwellings. While it's unlikely we'll pursue formal accreditation, we are taking the key achievable elements of BREEAM forwards in the integration of the scheme for the benefit of the client and tenants in the future. Now, this slide gives you a bit of information about the building fabric, quantifying some of the points Becky made earlier about the improvements we've made. The annotations on the right-hand side show you where we've got to with retained thermal elements and building fabric and the sort of U values that are being achieved, around 0.18 for the roofs, 0.3 for the existing walls, and 0.25 for retained floors. The annotations on the left show you where we're at now at the end of REBA stage 3 for the new thermal elements. So that's the extension at the rear and the new 4th and 5th floor, the sort of U value targets that you'd expect to see for those elements. Also, just to mention, we have looked at air tightness and stretching those targets as we see fit separately for the new build at 4th and 5th floor, and then a slightly more conservative figure for the refurbished dwellings. And then thermal bridging is something which is ongoing between the design team looking to minimize thermal bridging from a practical and also from a theoretical assessment perspective as well. So I mentioned renewable energies. We have a fairly extensive photovoltaic array at roof level of the building. We're proposing to configure this so the PV panels feed directly into the respective apartments rather than going via a landlord central distribution board. This was discussed and agreed with the client at the outset to try and maximise the benefit to each individual dwelling and the occupants, the tenants in the future. We've got approximately 400 watts per dwelling, and initial estimates suggest around a 350 to 400 kilowatt hour per annum reduction on consumption of grid electricity from this PV, but that's obviously subject to completing the detailed design as we progress. As you'd expect, we'll have low energy lighting throughout, and each dwelling will benefit from a high efficiency mechanical ventilation with heat recovery unit integrated in the utility cupboards for the purpose of ventilation. Early in the project, although not mandatory from a planning perspective for this project, we did undertake a overheating assessment following the CIBSE TM59 methodology. We felt this was important to assess the existing building with the changes being made to the building fabric to see where the internal thermal comfort was at. We looked at openable windows where possible. We looked at utilising enhanced ventilation rates from the MVHR units, and where necessary, we've looked at the possible deployment of tempering modules for the MVHR units to just bring down the supply air temperature in the dwellings if necessary. So we've had an acoustic consultant working as part of the team from the outset. A background noise survey was undertaken not only to deliver against our planning obligations for the suite of documents required, but it's also been useful to inform the design, taking background noise measurements from different points around the site. As you can see in the diagram on the screen, we were able to apply different criteria to different elevations of the building. So, for example, the blue line is the elevation facing the internal courtyard, and we were able to apply a slightly more relaxed acoustic criteria for this facade, which fed into the overheating assessments as per the previous slide. So it was useful rather than having a standard approach and solution to the whole dwelling. It was breaking it up and using the benefits of the natural environment that the building's within as we could. We've had fire engineers as well working alongside us from day one. We've got a fairly comprehensive fire strategy developed for the building, which has gone through the approval steps with the building control officer. Some key elements that they've helped us achieve: naturally ventilated basement for smoke venting purposes, achieving the required free areas into the architectural and structural solutions, so the respective consultants could develop their proposals to achieve that from early in the design stage rather than shoehorning it in later. We've got natural smoke shafts for the ventilation of the residential level common corridors instead of a mechanical system, which would have been slightly more disruptive with the associated plant required at roof level, and also the testing and ongoing maintenance obligations for the building within a conservation area and the associated acoustic challenges that throws up. As part of our fire strategy, we've got residential sprinklers provided throughout the building, fed from the boosted water system. And in order to achieve the duplex apartments, which Becky made reference to earlier, we've had CFD modelling undertaken. There are some slight deviations in those apartments from the prescribed format under Part B. So through the CFD, we've been able to get those agreed with the building control officer. A few points here on how our MEP team have approached the project with Fathom and Elliott Wood. It was important to, even before any drawing or modelling work had taken place at the outset, to share our thoughts and proposals on the services design to allow Fathom and Elliott Wood to be aware and develop their own proposals, cognizant of what would be required for the MEP integration into the building. We undertook early modelling in Revit of services through the building, getting all of the drainage stacks which run vertically through the existing slabs integrated, the core risers, services, distribution through corridors, and some typical apartments modelled early. And this not only conveys the spatial requirements, but it allows the proposed solution to be seen, but it also allows us to discuss as a team agreed secondary fallback options if there is, a floor slightly out of tolerance or a structural element discovered where we weren't expecting it due to the nature of the existing aging building. We can have fallback options in place that we can implement if necessary. Next, please, Becky. The final part I wanted to mention today was about the utilities and infrastructure. Some key points for this project: procuring a below ground services scan very early allowed us to identify where we had existing services crossing the landscaped area of the site and entering the building, so we could arrange any diversions or disconnections as required. Engaging with the statutory authorities from the outset, this was especially important on the electrical side, given the move away from natural gas and increasing the electrical load on the building. We wanted to establish with the DNO what capacity electrical supply we could secure for this building without triggering the need for an on-site substation, which, as you can imagine, would be fairly problematic to integrate into this historical building. So that was a key point of early engagement and dialogue with UKPN. And then the final point, as you'll have seen from some of the images, we've got extensive mature trees around the site with significant root protection zones. So agreeing incoming services routes with the statutory authorities, coordinated with those root protection zones, was something important to allow us all to progress the design in a coordinated manner. I shall now pass over to James from Elliott Wood, who will talk you through the structures for the project.
Thanks, Matt. James Hinks from Elliott Wood. I'll give a structural overview of St Mark's Court. So just a little presentation overview. We'll start with sort of how we came to understand the existing structure before summarising the existing and proposed proposals, and then get on to some specific structural solutions and how we overcame some design challenges there. So if we go to next slide, please. So the key to any successful refurbishment project starts with understanding the existing building. So from the beginning of a project, we start undertaking research with the aim of gaining a detailed understanding of the existing site. Now, the aim of this is to establish the facts. What we want to understand is the extent and the nature of the existing building, as only from a solid base of knowledge can the proposals be properly considered and allow for a truly collaborative design approach between the design team members. Now, on St Mark's Court, we're lucky enough, and there are a number of useful ways in which we were able to start building up the picture of what we were working with from an early stage. As mentioned earlier, we have the historic maps, which gave us ideas of the date of construction, plus the progression from individual terrace properties through to the mansion block. We were also able to get hold of archive drawings, so we had a better understanding of the existing layouts from back in the day, and we could start to understand and assume existing structure lines and where load-bearing masonry walls were to be expected. On top of this, we will always look at British Geological Survey borehole logs and maps to get an understanding of the existing ground conditions on site. And all of this starts to build a picture of what we have. In addition to this, then we start to go to a site walk around in which you get the sort of feel for the construction materials and the condition of the building. And from this base, we can then carry out targeted site investigations and opening up works on unknown areas and on areas to confirm that the knowledge we've acquired is accurate. If we go to the next slide, please. So putting all this together, we get an idea of what we have and with the existing structure. So at St Mark's Court, we have a traditional construction consisting of load-bearing masonry walls supported on timber joisted floors with a timber mansard roof, and it's founded on brick corbelled foundations. We can start to see that there are clear lines of vertical support from the perimeter, historic party walls, spine walls, and walls around the existing circulation core introduced in the change to the mansion block. Next slide, please. So from this knowledge of the existing structure, we can start to work collaboratively with the rest of the design team to come up with the best solution for the proposals in order to create high quality residential accommodation and the additional homes mentioned. So to summarize, the main structural works proposed here at St Mark's Court are a new basement under the full footprint of the building, plus extending past the building footprint in areas to create a large light wells. We have the removing of the existing timber mansard roof with the additional story plus a new mansard. We have internal alterations in order to create a more flexible and efficient use of space within the residential units and the extensions to the rear of the property. Now, the aim at St. Mark's Court here, and with most refurbishment projects, is we want to retain as much of the existing structure as possible while being able to achieve the ambitions of the proposals. To do this, using collaborative design work, we communicated and established some clear design constraints with the rest of the design team to work from an early stage, so everyone was on the same page. And these included minimizing openings through the historic party walls, as these are main structural elements that should be retained as much as possible, as well as where structure is required to be removed. We want to maintain those existing lines of support so that we allow for the maximum amount of existing floor to be reused and the existing load paths to be maintained. So with that basis of the proposed summary, I'll now touch on some specific design items and solutions that we ran through. So starting at the bottom of the building, we have the new proposed basement. So the new basement is under the full footprint, and it's to be formed by underpinning of the existing perimeter walls where possible. Where the proposed light wells extend past the building footprint, the basement is to be formed using contiguous piled walls. We will then construct the permanent structure of a reinforced concrete box inside that with a new raft foundation throughout. Now, the main constraints which need to be considered with forming the basement here were we have limited site access and the numerous existing trees around the building, particularly along Abbey Road. So the only access to site is through a small entrance on Abercorn Place, as the line of trees along Abbey Road block any other significant potential access openings to the site. In addition to the limited access, we also have a tree canopy height along that Abbey Road elevation, which provides a low headroom constraint for the works to be carried out in this area. These constraints would limit the construction types that we consider in forming the basement itself. So at the early stage, we got in touch with a few contractors in order to get some friendly advice from them on how we could potentially construct this basement both safely and efficiently. And we came to the conclusion that the contiguous piled wall using a low height piling rig, similar to that you would potentially use if you were piling within an existing building with limited floor to ceiling height. We came to the conclusion that that would be the most suitable construction method in order to deal with the limited access, the limited height from the trees, and also to minimize the width of the retaining wall in order to keep out of the root protection zones from the trees. So in order, yeah, that's good. Move up to the internal alterations. Now, as mentioned, the aim of this, we want to retain as much of the existing structure as possible. And we set out the design constraints early on to minimize openings through historic party walls. With that being said, we still have to be realistic with existing buildings with regards to the alterations required in order to be able to create a meaningful, flexible and usable modern space. So where openings were created and existing load-bearing walls were required to be removed, we replaced these with a new steel structure where we maintained the existing lines of support and the existing load paths enabled to resupport the existing timber floors. And this approach resulted in the proposed solution being able to retain approximately 80% of the existing timber floor joists on any given typical floor. If you go to the next slide, please. So with creating openings through the historic party walls, we also had to consider the existing building's stability system and the impact on this from the proposals. Now, in the existing case, the historic party walls provide the main stability system for the building. So where large openings were created, new steel frames were installed, and these were designed to support any lateral loads as well as the vertical loads from the floor. Where we were able to limit the opening sizes to smaller door openings through the historic party walls, the masonry will continue to provide the lateral stability in these areas. Now, we've proposed that brick testing is to be carried out when on site early on, when the contractor gets to the site. And the hope of this is to potentially reduce the amount of steel work which is currently in the proposal. As I said, these investigations will need to be carried out early on in the process on site so that we can allow for enough time to incorporate any potential design changes as a result of the results of that investigation. If we go to the next slide, please. So the last design item that I'm just going to touch on is the disproportionate collapse at St. Mark's Court. The existing building is Class 2A at 5 stories high. So with the additional story proposed, the building would be pushed up into a Class 2B category. Now, to upgrade a heritage property to suit Class 2B requirements, especially when that building was designed and built many years ago, without consideration for this type of guidance, it would be difficult to achieve, and not to mention it would be very material, time and cost intensive. So when dealing with existing buildings, we need to take a sensible approach, but obviously we still need to take a robust and safe approach to things like this. So at St. Mark's Court, where the design allows for applying the Camden rule, in which the new structure at 5th floor level will be designed as a crash deck, with the new structure above the 5th floor level designed to Class 2B requirements, so providing all effective horizontal and vertical ties, and the risk profile below the crash deck for the existing building can be considered unchanged. Now, the key to an approach like this, again, is working collaboratively and discussing the approach to be adopted with building control from an early stage in the design process. You want everyone to be comfortable with the approach being taken and to be on the same page so that there's no surprises down the line. So that's a summary of the proposed structure at St. Mark's Court, and I'll pass back to Rebecca just for a summary of the presentation.
Hey everyone, thank you for listening. Just a few take-home key points for you on our presentation. We always see existing buildings as a celebration and rather than a constraint, and by taking this approach from day one, it enables us to create unique properties and homes for the future. Undertaking a rigorous approach to the design and planning research of the historic plans for the building enables us to learn new ways of how to lay them out best and create buildings that are suitable for their context. Understanding sustainable ways to upgrade the existing building and making some decisions early on enables you to work those upgrades and fabric interventions into the scheme from day one. Developing servicing strategies that will drastically improve the operation of older buildings, again, is important to make some key decisions early on in the design process so that we can implement these throughout. And again, adapting older structures takes a creative and technical approach to making sure that we can retain as much of the historic fabric while creating new layouts and new homes that are fit for purpose. All of this can't be done without a collaborative approach between the design team members. It is important that both the design team and the clients are all on the same page, sharing their knowledge and expertise, and this enables us to create homes ready for the future. Thank you all for listening. I'm going to pass back to Patty for any questions. Thank you.
Thank you all for your presentation. We have quite a few questions, so let's start. So from Laura to Matt, you mentioned the building being intuitive for the residents, which is great. Can you say more on this? Do you also plan to do briefing sessions, walkthroughs, service guides?
I think one of the key points I was driving at there was not taking technology too far beyond what's right in the eyes of the design team and the client for the potential occupants and users of the building. Just because the technology might be there doesn't mean it's right to bring it into every project. Thinking about the audio visual provisions at day one, the lighting control, and just pitching it at the right point with the architectural design intent for the building. I think in terms of the handover and the soft landings of the project, that's something that we do advocate. In terms of how that will be implemented and rolled out in the future, I'm not sure. We're obviously only at REBA stage 3 at the moment.
Thank you, Matt. So we have another question for Rebecca from Mark Owen. How was Part E dealt with?
How was Part E dealt with? Well, I think for all of the different bits of the building regs, we've undertaken everything from straight away from day one. We've gone through all of the different stages of the building regulations and tried to work out what is appropriate, what we can upgrade and what we can't for the scheme, and taken a kind of approach on how we might integrate that with the existing structure. We're trying to retain as much of the existing floors, but because we will be removing some of the ceilings to upgrade fire, we are able to upgrade sound and passage of sound and flanking as part of this design. From having the acoustic engineers on board straight away at day one, we've got a set of criteria that we're working to. We're now developing those details. Again, as I suggested with historic, it is always about a compromise and what is suitable for that building. You push the boundaries of whatever you can achieve where possible, knowing that it might not be perfect in certain instances, but you can overperform in certain places and underperform in others. Thank you.
Thank you. A question from anonymous attendee, open to the entire design team. What is the proposal for space heating and hot water?
Probably best if I take that one.
Yeah, I was going to say.
In terms of space heating at the moment is direct electric panel heaters within the dwellings, and hot water is storage via calorifiers with electric elements. We did investigate options to utilize other technologies, both exhaust air heat pumps and more conventional air source heat pumps, but due to the cost and the space take either on the roof or in the external courtyard areas, those options were discounted, and at the moment we're going forward with the solution mentioned.
Thank you. From Maytal Ben Dayan to Rebecca. Was there an issue with the new solid brick walls in terms of compliance with building regulations as a new element with a higher U value than building regulations?
No, we're managing to work out the detail, and we're obviously at the detail stage now, but through balancing what is achievable with the existing building and the solid masonry and working with new breathable products, we can achieve quite a decent U value for those. And therefore we've got the flexibility to up-spec the new building fabric elements for our new facades. We're looking at brick cavity wall construction where possible, using timber within that. And we allowed from day one space zones for the facade to enable us to achieve really high U value rates. We're currently actually in a bit of review to see if we can up this going forward to the design stage and make them even more performance.
Thank you, Rebecca. So from Claire Truman from Matt, is the impact of embodied energy to create this scheme being measured with respect to carbon payback? How many years is it expected to be that this will become carbon neutral and then positive?
So we haven't undertaken full whole life carbon assessments for the project. It wasn't a deliverable for planning. The general principles we're trying to apply to the design, retaining structure, retaining architectural elements where possible, follows the principles, but it's not something that we've quantified at this stage.
Thank you. There's another one for you, Matt, from Shams Namazi. You mentioned the design commenced in 2021. When was the application submitted, and when did Westminster require an assessment against Part L 2021? If so, what was the outcome of this?
The design was commenced in 2021, and as such, we were working to the Part L 2013 regulations. And in terms of, I can't recall the exact date that a building regulations submission was made. I don't know if Becky's able to answer on that point.
We registered the building regulations probably about 5 or 6 months ago, prior to the date. We're actually on site starting to look at underpinning as we speak. So we will be working to the building regs for 2013. In the background, we are looking at the implications of improving those and where possible to meet the new U values for the new updated Part L building regs, and where we can, we will be implementing these. But the scheme was currently designed prior to this.
Yes, sorry, Patty, just to add to that, we're just in the process of running an assessment of the building against the 2021 regulations. Something that's just going on at present. So I don't have the results to share with you, but we are, like Becky said, looking at where we can future-proof on the thermal elements and things like the electrical supply for alternative servicing strategies, should they be required by the client in the future.
Thank you. Just for final questions, if you could send them in. I have one for James. Were there any particular challenges in making the scheme viable when uniting the approach to design, structure, and services was key?
I think, as we said, that the main thing with this was to retain as much of the existing structure as possible. Obviously, one option could have been to, a facade retention job on this, but it didn't feel like the right thing to do. And by setting those design constraints really early on within the design process, everyone's working to the same sort of hymn sheet, and it was a lot easier to work collaboratively. With horizontal MEP service runs, we've tried to target those in areas of corridors where we're going to have new steel structure, so we can oversize openings slightly to allow for service runs and things like that. So it always comes back to working collaboratively, I think, and making sure all assumptions are clear within the design team.
Thank you. And one last question. How difficult has it been to get costs for the scheme to stack up? This is for Rebecca, and it continues. The approach appears to involve quite expensive elements, from additional floors to meet the sprinkler for the entire building, new basement, etc. Was it difficult to get the client to commit and agree to this?
No, in all honesty, I think from day one, we were always all working together as a design team, and we've had the QS and the cost guy in every single meeting. So we have all been designing to what's achievable. Part of the key to getting a scheme like this to stack up is about making sure that there is a give back. So by doing the basement and the additional stories on the top, we are able to create new homes, and that ultimately can therefore pay for the upgrade to the rest of the existing building. It would be very hard to achieve the scheme without those new additions and that new additional area that's created, and then make the upgrade, for example, to the insulation or the windows and everything else stack up. So when you view the scheme as a whole and all of the component parts, it is balanced viable. And yeah, we're hoping to look forward to it going on the market soon when we've finished construction.
Oh, it's exciting. Thank you. I think we have to wrap up the presentation of the event today. Thank you, Rebecca, James, and Matthew for being here. And thank you to our audience for attending the webinar. If you have any further questions, you can contact the speakers directly, and the webinar will be available online shortly.